Welcome to homework.
All right, we've got NBr3. Oops. That's the total number of valence electrons. Well, nitrogen brings 5, and bromine brings 7, but there's 3 of them, so we'll do 3 times 7. We'll get 5 plus 21 equals 26 electrons. So our Lewis dot structure looks like you've done correctly. Is as follows. So there's 8 for each of the bonds to bromine and bromine itself. So that's 8, 16, 24, and then 2 additional on nitrogen makes 26. So that is the correct number of electrons. A 3D sketch of the molecule might look slightly different. For example, we could have nitrogen on top, and we could say it goes down to bromine on the left, down to bromine on the right, down to bromine in front. It looks something like this. But I would still want to include the lone pair on nitrogen. That might be a 3D stretch. I'm unsure how you need to exactly to sketch it, but yeah, it looks like you have a pretty good sketch, and I don't know if you're supposed to include lone pairs or not, but if you are, there would be one on nitrogen in the 3D sketch. The sketch you have, I think, looks okay, honestly. Identify the shape of the molecule. This is, here you've got an issue. This is not tetrahedral pyramidal. That's not a thing. This is trigonal pyramidal. Right? Trigonal pyramidal. Okay. What type of bonds does this chemical have? Polar covalent, covalent, or ionic? Here, if you need to show your work, right, that's going to be based on electronegativity of the atoms that you have bonds between, right? So, for example, you've got a bond between nitrogen and bromine. The electronegativity of nitrogen is 3.04, whereas for bromine it's 2.96. So their difference in electronegativity is 0.08. That's very small. This is why you have covalent bonds, right? Small difference in electronegativity means covalent. This is really sloppy. This is 3.04 minus 2.96 equals 0.08. Okay, which atom is more negative? Well, we just figured that out, right? 3.04 is nitrogen. Nitrogen is the more negative atom, according to a periodic table of electronegativities. But, refer to whichever electronegativities you've been given in class. Since these are so close, they can sometimes take on different values. It really depends on what your textbook says. Is this molecule polar or non-polar? Right, so here you're meant to be looking at the polarity of these bonds, right? From bromine, which direction should it be facing? In the direction of nitrogen, if it's the more electronegative atom. Furthermore, this lone pair is going to cause a dipole that looks up. So if we view this from the top down, we get a triangle of bromines around nitrogen, and each will have a dipole pointing in, and in fact, in this sense, they'll all cancel out, right? All 3 of these dipoles that are the portions of them pointing in at nitrogen will cancel each other out. However, the portion of them that's pointing upwards will add to each other, right? So in fact, the net dipole will have no horizontal component in this sense, but the vertical components of the bromine nitrogen dipoles and the nitrogen lone pair dipoles will all add to give a dipole that points upward through the lone pair. Right, so if we were to view this from the side, it would kind of look like almost like something like this. Right, it's all this vertical component.